Take it away.
All right. Yay. Woo! Get excited. It's almost lunchtime. So, as stated, I'm Adam Baldwin. That's where you can find me on the internet. I'm from a wonderful place called And Yet, where I run the Lyft security team and started and coordinate the Node security project. And I'm here today to talk about the art of identifying vulnerabilities. And so back when I stepped out of the security community in 2009, and I stepped into the world of devs, I did my first conference talk at DjangoCon 2009. And I was an outsider coming into the developer community, and I wanted to take the knowledge I had from the security community and go to the source of where bugs were formed, right? Developers, and I got the question. I immediately got the question. How do you do what you do? How can I do what it is that you do? As if there was some mysterious thing that we did that was different and make my code better. And I was very ill prepared to answer that question. I thought that I'd be able to explain things better, and it's taken me since then until now, until actually putting together this talk to figure out what those things might be, and actually distill it down into sort of what could be a repeatable process. And that's what I'm going to share today is my thoughts and perspective on this, and it's going to probably jump around a bit. To me, it feels kind of like the Matrix when I look at an application, and things just feel a certain way, and I look into those nooks and crannies. So I'm going to do my best to put that in a linear format for you. We're going to start with not changing slides. So what is a vulnerability? What is vulnerability? What are we looking for? Is it a bug? Is it simply a bug? And I think that's true. Is it a weakness? That's my favorite security fail picture of all time. Yeah. Vulnerability is just a weakness in a system. It's the weakest link in the chain. To me, a vulnerability is a promise that can be broken. This is a patent picture of a lock. Locks, give a promise of some type of security, but you can pick them. Or a padlock, you can shim them with a little piece of aluminum from a soda can. But we're looking for things that can break the promise of confidentiality, integrity, and availability. Things that create weakness, but most importantly, we're looking for bugs that we can fix. That's the saving grace here. Is that they're just bugs? We can fix them. There's nothing to really worry about. So here we go. To find vulnerabilities, you need systems knowledge, you need security knowledge, and you need my favorite part of all, curiosity. So systems. Vulnerabilities grow in the cracks between nuances and assumptions. To find vulnerabilities, you must understand the nuances of the systems that you create and consume. In JavaScript, what the heck is the event loop anyway? That's a great, that's a complex thing that we have to deal with. This is a great talk by a team member of mine, Philip Roberts. If you want to, know more about the nuances of that. I'm going to stay a bit high level in some of this. That's something that if blocked, right, we have vulnerability against, or we have an attack against availability, right? Some other great resource. I know you can't read. If you can't read them, the slides will be available. Some other places to find and understand the pitfalls of JavaScript nuances. Things like the equality table, right? It's super confusing, and also the other one, You Don't Know JS, is a great book series. You have an interesting advantage as developers when it comes to systems as compared to an outside security individual, is that you're closer to that code. You have a deeper understanding of that code and how those things are put together. We, on the other hand, from the outside, when we have to audit code, we have to figure that out very quickly. Anyway, I'm babbling. Okay, so hopefully you saw Helen's talk yesterday about prototypical inheritance. Another really interesting nuance thing about JavaScript, right? And the surface area is growing as we get ES6. It's growing more complex. Here's my favorite nuance of JavaScript. It seems so simple, right? The double equals, right? It's just something that we take for granted. We use it probably every day, double equals or triple equals. Does anybody here know actually how that really works and could tell me? It's on this slide. You can't read it. Basically, ECMAScript 262, like there's tons and tons of like conditions that it goes through as it compares a string to go from, to compare equality. And we can abuse that as attackers to guess strings that we can't see because of timing differences. How far down into this chain of events can we get, byte by byte, and we can guess that. And so you should use, constant time comparison functions in like crypt utils or like the bcrypt utilities or something. That's my favorite nuance. It's so simple. It's so often ignored. And again, system stuff. Vulnerabilities are prevalent between one system and another. So as you're going to find vulnerabilities where data changes hands between one function and another, or a client to a database. But it's not just about the code that we write and the data flowing between that code. It's also about other systems that we use and consume. Who here uses NPM on a very daily basis, right? Probably the majority of the people in the room. I do myself. I love NPM. It's a system that provides input into the applications that we write, right? We add dependencies to our project from other people. We're taking untrusted, maybe trusted, client input and putting it into our projects. Whose code are you really running in production? That's an interesting question. I really like the data visualizations from yesterday of how those dependency graphs look and things like that. And that really shows the power of just one individual and one individual's account and how that affects the entire your dependency tree. This is just a simple graph showing that the red dots. I have it blurred out because I don't want to say basically who it is. That red dot shows a maintainer, and it shows their packages, and it shows the packages that depend on those packages, and so on and so forth. And the more popular you get, the more impact. And who here has changed their NPM password in the last 90 days? Don't lie. Right? It goes into a config file. We don't change it. But really, you're relying on the security of others in that network to provide security in your application as well, right? You're taking that input. So take it into consideration, rotate those credentials as well. To find vulnerabilities, they multiply in the complexity or in the presence of complexity. If you're running Node in production, you probably got to update yesterday because of some OpenSSL vulnerabilities. OpenSSL, the crypto library, is insanely complex. It was just a simple bug, but it allowed you to basically man in the middle and impersonate a cert. And that's 300,000 lines of code. It's complex. If any of you, we trivialize and say, just make a request to the server. There's an amazing amount of complexity that happens down the entire, the stack from application down to the network and back again. The thing there is I can be contrarian and say, and the example that I'm going to show you at the end goes against that, and will show a module that is really very simple, yet has a vulnerability in it as well. So don't let that be deceiving. Complexity is where they thrive, but something as simple as just a few line module can have a vulnerability as well. And I just love this tweet. So sometimes I marvel that every computer isn't on fire all the time. So security. We've talked about systems. We talked about the fact that we need to understand the nuances of the things that we create and consume. So let's put on our security hats. This is, I'm not a black hat hacker or a white hat. I'm a pink hat hacker. I don't know. So where to start, right? So if we're talking about security, where do we want to start? And what I thought would be of interest is this phrase is always thrown out. As you're going to find vulnerabilities or identify things in applications, you need to think like an attacker to defend your application. What the hell does that actually mean? Okay, so I asked my team to give me a couple of quotes. John says, I locate the intuitive trusts in the relationships between developers, software, and users and manipulate them. The trust that happens without conscious decision, like a person sitting in a chair, assuming someone hasn't removed one of the legs since they last sat in it. How many of you checked how many legs were on your chair before you sat in it? We make these assumptions as we use the systems we create and consume, and sometimes those legs can be pulled out from under us. And John says, then he determines how he can redirect those trusts towards himself without making either party aware. Matt on my team says, thinking like an attacker to him means that we try to push the boundaries of useful things to see how we can get them to do something that it wasn't designed for. A simple example would be a screwdriver. It's very useful for its intended purpose, but it can also have nefarious purposes as well. To me, again, I look at when I'm given a piece of code or an application to audit, I think about what promise, again, going back to the promise, what promise does it make? And the reason why I mention this is because this is really useful for module auditing versus an application where you have an entire stack end-to-end. If you have a module, the thing is that it can be used in many different ways and many different purposes in many ways you didn't intend. The vulnerability exists in a module when it makes a promise and it doesn't satisfy that promise. As an example, the marked library can sanitize, take markdown and sanitize it so you can use it in a browser so you don't get cross-site scripting injection issues. However, that can be, in one version you could put VB script in there, and it would be, in certain browsers, it would bypass that. So it makes a promise that it sanitizes, yet that promise can be broken. That is a vulnerability. So that's a good example there. And also, I look at it when I ever look at an application or from a service perspective, how does it make money? Those are the important things to protect. Is again confidentiality, integrity, and availability of protecting that core thing of how it makes money. And availability often gets forgotten. Availability, however, it is a security concern, and it's the most felt by your users. If something is down, it's going to be felt by your users. If something is, if something can be sniffed on the wire, it's not as impacting. It may be just as severe, but it's not going to be as felt. So now we've talked about system stuff, security stuff, but how do we gain knowledge about sort of attacking these nuances and assumption? The standard one, if you haven't heard of the OWASP Top 10, that's a great place to start. It gives you 10 areas in which you can focus your efforts in learning about vulnerabilities and abusing applications. From injection to misconfigurations, all those types of things. Please, if you haven't read this, and just spend a little bit of time there. Also, this one I really love. If you want to know how to get better at hunting security bugs, read security bug reports. And the thing is we don't have a lot of vulnerabilities in the ecosystem. We've got some out at the Node Security Project advisors. You don't have a lot of detail there, but that's where you're going to get. That's where you're learning from basically others, learning from other platforms. This thing doesn't click. Learning from other. This is a great resource from other languages that have. Basically, you want to learn from their mistakes. If we don't, we're resting on the shoulder of giants, and they've solved these problems, and we're just another language in that. We should rise up to be better than just make the same mistakes as other platforms before us have done. There's no need to reinvent the wheel the majority of the time. Now, finally, I get to my favorite section of all is curiosity, because you can have all of the knowledge about systems and all of the knowledge about how to abuse those systems, but if you don't actually get off of your rear end and actually look, you don't find anything, right? If we don't actually take the time, take part of our day, part of our sprint to look for these things in our code and our systems, we're not going to find anything. And my favorite way to put it in motion is to act ridiculous. Calculated reckless abandon. That's my daughter. She's wonderful. But it's stimulus response. Do things to your application that you normally wouldn't. Don't basically shed all prior knowledge. Act like a child. They want to get into something, they're going to get into it. They're going to bypass whatever child lock you put on there, or they're going to manipulate you socially to give them whatever you want. And this, again, you could just throw in proto _ proto everywhere. You know, a nice nuance to JavaScript. How many have tried to just throw it into every input field that they've found in their JavaScript application? Things break. Lots of things break. And then, this is my son on a rocking horse on a skateboard. Just because. How can it be used in other ways? How can, how is a user going to use your application? That, like, what assumptions are you making, and how can it be used? I mostly want an excuse to use that video. So, another tip is avoid or ask questions and avoid statements. One I hear often is a user would never. That's a big red flag. It's like throwing that penalty flag. If you ever hear yourself saying that or hear a coworker saying that, nope, we need to have a test for that. That's just, red flag. And in the end, it's more about what you don't know than what you know. You have, like I said, you as developers are close to your application, so it's really easy to be blinded by the assumptions you made while writing it. And so, again, bouncing that off of that peer, having a peer review is good. But try to shed that knowledge, and doing so by just acting ridiculous, throwing strange inputs. They call it fuzzing. It has a term. Throw random stuff at your application. So that was kind of like the high level, like what I think about when I'm thinking about systems and security and how I put that into motion in a very like light sense. And now we're gonna do just a little like demo. This is her hacking. He's like, okay. And this is the process that I go through. This is like the TLDR, or like too long, was boring, didn't listen. Basically, I look at the code. I understand the threat model. What is it used for? What does it do? What's it intended to do? Identify the inputs. The things that are take in data into the application. Identify the sinks. The sinks are basically those functions that are, if something from a user, or if certain behaviors ends up in that function, like eval or a regular expression or a file system write, or if a sink is one of those, if it ends up there, it's bad. You've traced those things, you've test and validate, and you repeat. And yes, it is actually really boring, and it doesn't look like anything like hacking in the movies. It's just typing. So let's see if I can learn how to use this and show you what I'm going to demo. That didn't work. Okay. So let's instead, that's for, okay. Wow. Okay, so I have, that's actually somewhat legible. So what we're going to look at is a module called MS. Of course, the network's not going to work. We're going to look at a module that does millisecond time conversion. Who would expect a vulnerability in a module like this, right? Few people. Okay, because they're going to find one. Okay, so I didn't. And we audit modules, and like we just have to do it. I have to go through and look at this. This is part of my job. And so it's like started looking at this module. I'm like, okay, it does time conversion. It takes in some strings and some arbitrary values, and just dumps out milliseconds. Okay, so that's great. We know what it does. Now let's go look. If you go look at the actual module. And you go through it. It has one module exports. It, again, takes in a value and some options, and then does some things, right? So if it's a string, it passes it to parse. So we're going to go follow it down into parse, and parse then compares it against a regular expression. So that's my first Eric, it goes into a regular expression. In a regular expression, once you gain that security knowledge and that systems knowledge, you know that regular expressions are actually a nice sink. And so if we didn't know that, we might say, okay, a regular expression. What regular expression, do they have any known attacks? Well, we put regular expression attacks into this wonderful computer-y machine thing. We get, we find and we can gain knowledge on the fact that there is a thing called regular expression denial of service. So given the right input, the right regular expression and the right input, we actually can end up with a denial of service condition. We can block that wonderful event loop that we want to keep, spinning our callbacks. So we go back and we say, okay, we have a regular expression. How do we know if it's vulnerable? We could read that paper. There's a really cool module from, of course, Substack. There's you could run it through this module called SafeRegX that'll tell you if that regular expression is vulnerable to regular expression denial of service. It's really cool. We're not going to do that, but another way is to just kind of look at what that regular expression looks like in this debugx.com, and this is not going to show up well, but just plug it in there, and it shows you visually what it's doing, and it wants a decimal, dot decimal, and then something on the end. However, if you look, when you start putting input in here, as you go along, so it matches, but you can see that it also wants, we can still put in those other characters at the end, so we can just keep putting decimals, and the input can be as long as we want, and then we can put like minute, and then it matches, and we just put some other random character in it, and it fails. What? That's fine. It's not really blocking anything. However, if we exit this, this is a little test thing that basically just generates a really long string, whatever I wanted, and then adds like the minute A at the end, right? So I'm going to say whatever I pass it in for a length, generate a big long string, and then throw this on the end of it and pass it to MS to see if it parses it. And so if we run, like I did in the example, 20, right? It goes really fast. But as soon as we start adding on, like if we go to like 10,000, starts slowing down a little bit, and we double it, and these are still values that are very, very small compared to the max size for most HTTP requests. So if you happen to be taking this onto a server, that starts increasing as that time that it's blocking keeps increasing. And different regular expressions you run into will, in fact, have different amplification amounts. And so that's basically how I followed it through. And there's little utilities that can help you with in those different OAuth categories of like cross-site scripting or cross-site request forgery or denial of service or what have you. There's tools that have been created to help test these things. They're not always developer friendly, but they do exist if you go looking for them. And so it just it amplifies quite a bit. Guillermo basically blocked the attack, was saying like, okay, it can be 1,000 characters long or something. And it's like it's nullified, so it's really easy to mitigate in a lot of issues or a lot of situations. So that was basically the demo. Very simple, like walkthrough of sort of my process, and I've got some. So like this again, we went through and understood the code. It doesn't use any built-ins. It doesn't use any, we understood it. We followed the data from sources sync after we identified the inputs. She's going to hate me someday. We identified the syncs where it went, and this is something I didn't show, but something that we use often too is ESGraph is a great utility to do call flows to see how data flows between inside of an application. Just an example there. It's another tool to be able to use. We tested and validated. We looked at how those how it worked and how we got that amplification, and then that was really it for the demo. Once you go from manual auditing and you understand how to find these things from a manual perspective, you can take it into an automated area. And so we've got a set of, whenever we identify one of those syncs that could be bad or a pattern that could be bad, we make ESLint rules for internally. And so we run, so I've got this tool called EPLint. evil packet lint, that runs eplint like index, and it just runs and it tells me, hey, there's a regular expression so it found the regular expression by parsing the AST. It gave me the regular expression. I ran it through safe-regex, and it flagged it. There's some false positives, but it shows up. So I can take this now and run it over every module in the NPM ecosystem and now start flagging those and find those vulnerabilities. And it's really easy for you to do as well. Those are up on my github.com/evilpacket. There's some ESLint rules up there for this particular one. And also you can do, I'm out of time. So if you want to know other automated stuff that I've been working on, come talk to me afterwards. Like, I'm really excited about using Docker to find like malicious modules that have like install scripts, stuff like that. Really interesting stuff, ways of finding vulnerabilities automated. Final message is be okay with boring, monotonous, and unfruitful testing. Just like a cat trying to get into any size box. Be persistent. You will find vulnerabilities. My last note there is don't try to do it all at once. Pick one of those categories and learn a little bit more about it. Share it amongst your team, amongst the community. Write some good blog posts about these things. We need more about it in the Node community. That's it. Thank you.